Hi, my name is Ashita, and my topic for today is hospital discharge decisions. The reason why I chose this topic is to address the problem of unnecessary hospital readmissions. Firstly, why do they happen? Well, one of the reasons is improper discharge decisions. For example, if a patient is discharged too soon, let's say after a surgery, he might develop a post operative complication. This physician's judgment depends on a very small evidence base, and that's mostly based on his experience. Therefore, he might not take into account a lot of factors which he ideally should. So, what are the effects? Well, unnecessary readmissions affect patient life by not only causing discomfort, but in more serious scenarios, even death. They cause a waste of expensive healthcare resources. A needy patient is deprived of those resources, and they also have an effect on the cost. So, can you think of any solutions? Well, firstly, what are the drivers of readmission in patients? They could be suffering from a chronic disease and therefore have frequent readmissions. The patient could also have multiple comorbidities. For example, a patient with both disseminated cancer and open wounds are at nearly double the risk of readmissions than those without. Coming back to the main question, can we improve the discharge decision making process? The answer is yes, of course. With the advent of big data technologies such as Spark and its machine learning libraries, and the availability of healthcare data, we can do a great deal of analytics on it. The goal of my project is to basically build a decision support software which can help the physicians in making a discharge decision. This can help reduce readmission rate and also help reduce the patient's length of stay. So, my ultimate goal is to classify patients as 0 or 1. 0 being do not discharge the patient until the physician is absolutely sure, and 1 being the patient is ready for discharge and he can go home. So, now looking at the cohort from the Mimic3 database, there are about a total of 46,000 patients, and about 7,500 patients were readmitted. But more importantly, about 2,600 patients had unplanned readmissions within a span of 31 days, and that is about 5.74%, which is a big deal. Looking at this table, we can see that the number of patients was about 5.74%, and the number of admissions was about 14.51%, which is again a very high number. So, what are the major reasons for unplanned readmissions? After doing some analysis, these are the reasons that I found. And as you can see, most of them can be avoided by preventive or precautionary measures if they're just suggested by the physician at the time of discharge. And these are the major reasons for planned readmissions. And as you can see, newborn is about 18.59%, which does make sense because a lady would plan to get readmitted if she knew that she's expecting a baby. So now let's talk about the model that I've built. I've used Scala 2.1. The data is stored on the Amazon RDS server. I did all data pre-processing using Postgres and pgadmin3. For selecting my data, I used again SQL commands, and I removed all missing valued rows. Then I also built multiple views using SQL commands, so I could join tables that would help describe every patient's history of diagnoses and procedures. And then now for the feature construction part, this is what I did for every single patient. I collected the set of diagnosis ICD-9 codes and the procedure ICD-9 codes, and then I merged them together to create a feature vector. For every ICD-9 code, I also mapped it to an integer as the ICD-9 codes were strings. Now, as you can see, I have a huge feature space. That's why I created sparse feature vectors, which basically consisted of the patient's class label, feature ID, and feature value. Feature ID was the mapped integer value, and the feature value is the count of that particular feature ID. So for a patient, it would be the count of a particular diagnosis and the count of a particular procedure. Then I converted the results to an SVM Lite format using a Python script. And now for the model, I used 3 different classifiers for training and testing: SVM with SGT, decision trees, and logistic regression with LBFGS. I split the patient's feature data into training and testing in the ratio of 7:3, and then I trained the model, and then I tested the model, and then I used AUC score to evaluate the performance of the model. And here are the results. So as you can see, for decision tree, I obtained a score of 0.68. For logistic regression, I obtained a score of, again, little more than 0.685, and for SVM with SGD, it was about 0.701. So yes, that was it. In terms of the feature scope, this is what could be done. You can add more features such as vital signs, SAP score, and gender, and then you can also identify the most significant set of features. I think even some sort of comorbidity analysis would also help to understand how various diagnoses and procedures influence each other, and they might just give better results. I don't know. And now, to summarize, proper hospital discharge decisions can help reduce readmission rate. A physician may discount the suggested discharge recommendation. And most importantly, creative strategies to incorporate the best data analysis with display modes are a necessary step for the uptake of such a decision support system. Thank you.